In this video, we are going to go over the Mock 2 review, which is our second test of the semester. So, this first one says choose which properties apply to each quadrilateral, apply all, or choose all that apply. So we're going to work through these one at a time. So opposite sides are parallel and congruent. Well, that's all of them because they are all parallelograms, okay? So we're going to put A for all of them. And then the next one is diagonals or perpendicular. This applies to a rhombus, which means it also applies to a square because a square is a rhombus, okay? Then it says consecutive sides are perpendicular. So this would be a rectangle and a square, right? That means they have right angles at the intersection of the sides. D is all sides are congruent. That would be a rhombus and a square. Then diagonals are congruent. This is a rectangle. And a square is a rectangle. And then the last one is diagonals have the same midpoint, and again, this is all of them because that is a property that applies to a parallelogram. Now these are the properties you need to know to be able to accurately answer later on in the review questions 7 and 8. Okay, so you need to memorize these properties if you don't already know them. Given the points x, y, z, write a rule for what change and then state what type of transformation occurred with the images below. So we're looking at these values right here, and we're going to compare them to x prime, okay? So I noticed they did not flip, so I'm going to just write x, y. Then I'm looking at did one of the signs change, or in this case, did both signs change, and they did. So that is a 180-degree rotation. Now here again, these are rules that you need to memorize, okay? So this next one, again, comparing it to negative 5, 2, I noticed immediately that they flip. So I'm going to put y, x, and then we're looking at the signs of the terms. The 2 stayed positive, the 5 stayed negative. So it's just yx. So this is a reflection over the line y equals x. Okay. The next one, 5, 2, again, started with negative 5, 2, so this did not flip, so this is still x, y. What changed? The sign, right, of the negative 5. Changed to a positive 5. Okay, so this is a reflection over the y-axis. So remember, when only the x or y changes sign, it's a reflection over the x-axis or y-axis, right? This is y-axis because it was the sign of the x that changed. Okay, so the next one is 2, 5. Again, we can see that it flipped. So this is y, x, and it changed from a 5, or from a negative 5 to a 5. So we're going to make that negative because that means the sign changed. The 2 stayed the same, right? Okay, so what transformation is this? This is a 270-degree or 90-degree clockwise rotation. Okay. All right, so the next one is negative 5, negative 2. Okay, so what changed here? Again, looking up here at our signs, negative 5 didn't change. The 2 changed signs, right? So this did not flip, so it's still x, y. The 2 changed signs. So that is a reflection over the x-axis. All right, now F says 2, negative 5. Okay, so 2, negative 5, they did change, so it's yx. Again, keeping in mind what my original point was, it was negative 5, 2, right? So negative 5, 2, the negative 5 didn't change, but the 2 did, right? So we're going to say negative yx, so this is a what? 90-degree or 270 clockwise degree rotation, right? Okay, so the next one, again, it changed, right? So it was, look up here again, negative 5, 2. Okay, so it was negative 5, 2. So it changed to yx, and negative 5, 2, both signs changed, right? So if it's negative y, negative x, then it's a reflection over the line y equals negative x. And again, these are rules that you guys need to commit to memory. And the best way to do this probably is with note cards. flashcards, you know. So it says, what is the translation vector given points 2, -1, y, x, y, z, okay, prime. So we're going to pull just our x here. So again, it's -5, 2, so I'm going to bring it down here. X was -5, 2. So what we're going to do is we're going to look at what the change was. So these are completely different numbers, and that is an insight to me that this was a translation. So we're going to say 2 plus x equals -5. That's going to give our x value. So we're going to subtract 2 from both sides. So x is equal to -7, right? And then we're going to do our y value as well. So we're going to do the same thing with y. So -1 plus y equals 2. So we're going to add 1 to both sides. So y is equal to 3. So what vector is that? That would be exactly those numbers. So the vector would be -7, 3. The rule would be x minus 7, y plus 3. So the transformation was 7 left and 3 up. Okay? So now it says which two transformations will map a BCD to BCD double prime. Okay, so we're going to go from BCD to BCD prime. So I'm not going to use this point right here, B, and I'm not going to use D because of the 0 and the 1. Okay, so that doesn't help me because it doesn't give me 2 points. So I'm going to use point C. So C was -3, 2. And then I'm going to look at my C prime down here, okay? So C prime was -2, -3. And let's try to roll for that, okay? So you should be able to see that these definitely flipped, right? So it's going to be y comma x. Which one changed signs? The -3 is still -3, but this one changed signs, right? So that's the rule for a 90-degree or 270-degree clockwise rotation, right? So that's our first rule. And then we want to look at C prime, which is -2, -3, and how does it change when we go to C double prime, okay? So when we go to C double prime, that's going to be 1 comma -3, okay? So notice that's a completely different number, okay? And that's a hint to me that that was a translation. Because anytime you have rotations or reflections, they're the same numbers, right? So this is not, okay? So the other thing is we can count 1, 2, 3, to the right it went, right? So if we talk about a rule here, this would be x plus 3, right? Because we moved 3 to the right. My pencil is not switching. X plus 3, and y didn't change at all, okay? So what does that mean? It went 3 right. Didn't move up or down, just 3 right. And it moved by the vector, what? 3 comma 0, okay? Wrote it all 3 ways just in case you see it in any different type of representation. All right, so for number 4, it says what single transformation will give the same result when we do B with a first transformation is a reflection of line y equals x, and then a second transformation followed by a reflection over the line y, the axis, the x-axis, okay? So I'm going to show this to you here, and then I'm going to show you a different way to do this so you guys can think through it when you're actually taking the test, because there's not going to be points on the test. Okay, so if we're doing it this way, we have B, our first B, which was -4 comma 3, and then we get our B double prime. Where did we go to ultimately is the question, right? So that we got 3, 4. Okay, so what rule can we get there? Obviously, all of y'all can see they flipped, right? So that's yx. The -4 changed to a +4, didn't it? So that means that sign changed. The 3 did not change sign. So what is this the rule for? Again, a 270 or 90-degree clockwise rotation. So here's the thing you need to remember. Any 2 reflections always equals 1 rotation. Okay, any 2 reflections always equals 1 rotation. I'm going to do the next one, and then I'm going to give you all some tricks of the trade, if I could call it that. Okay, so here we go again. We got our B, and that is -4, 3. Okay, and then we got our B double prime, and so this one is -3, -4. Okay, so once again, notice they flipped. So it's y comma x, right? So -4 is still -4, but now we have a -3. Okay, so what is that? That is a 90-degree or a 270-degree clockwise rotation. Okay, so now I'm going to show you some tricks. Okay, so pause a minute. I'm going to talk you guys through some different rotations here, okay? So if we've got an A up here, okay, and I tell you it reflects over the y-axis, it goes over here to quadrant 2, right? So now it would be A prime. Now if I told you it reflected over the line y equals x, where would it end up going? Down here, right? So this is my A double prime. So what kind of rotation would this be? A 270-degree rotation. Y'all see that? Okay, I'm going to show you a couple more. So here again, I got my A. And if I reflected it over the x-axis and brought it down here to quadrant 4, right, that would be A prime. Now if I told you I reflected it across the y-axis as well, it would come over here, and that would be A double prime. So again, what is my rotation? That is a 180-degree rotation. So you guys can think these through, okay? So we're going to show you one more. So I'm going to do, again, let's see. I'm going to do an A here, and I'm going to reflect it over the y-axis. I'm going to, no, you know what? Let's do this. Let's reflect it over the line y equals negative x, okay? So when we do that, it comes down here to this quadrant. Now if we reflect it over the x-axis, it's going to come up here, right? So that's going to be my A double prime. So how far did this one rotate? 90 degrees. You got it, okay? So you can think these through, logic them out, okay? So, number 6 says, using the figure below, find the expression that will find the total area. Okay, so what we're going to do is we're going to find this top one first. To do that, we're going to multiply. Remember, area is base times height, right? So we're going to do the box method here. So I'm going to do 4x and 9, and I'm going to do 3x and minus 5, and I'm going to find the area of this top one, okay? So 3 times 4 is 12, x times x is x squared, 9 times 3 is 27x, 4 times negative 5 is negative 20x, and then we got negative 45 here. Notice that we have like terms right here, okay? So we're going to go ahead and combine these. So this is going to be 12x squared plus 7x minus 45, okay? Now what we need to do is bring this 4x plus 9 down here because we've got to find our base, and then we have our height, right? We already have our height. So we're going to add 4x to 8x. That's 12x. 9 minus 4 is 5, so that's plus 5. So now we're going to multiply these two together, and we're going to add the two areas together once we find them. Okay, so we're going to do the same thing we did before here, 6x and 2, and we're going to do 12x and 5. Okay. So 6 times 12 is 72, and x times x is x squared. So this is going to be 24x. Then we've got 30x. And then 5 times 10, 5 times 2 is 10. Okay, so here we have our like terms again. So now remember, we're going to add this. We're going to combine our like terms there, the 24 and the 30. So this is going to be 72x squared plus, what is that, 54x plus 10. So now we're combining our like terms to get our answer. So that's going to be 84x squared plus 61x minus 35. So that is the area of the whole thing, okay? So I went ahead and plotted these, so I'm going to label them J, K, L, and M. Okay, so it looks like a rectangle to me. Okay, so let's talk about what we know about a rectangle. So with a rectangle, consecutive sides are perpendicular, right? So, well, first of all, let's just talk about the length of sides. Okay, so this side right here is 3, this side's 3, so we could say that MJ is equal to LK, right? Then this side up here is 6, and this side down there is 6, so we could say also that ML is equal to JK, so we can see that opposite sides are congruent, right? Okay, then also because we have a vertical line and a horizontal line, we can say that ML is perpendicular to LK, and then LK is perpendicular to KJ. KJ is perpendicular to JM. And then we could say JM is perpendicular to ML, okay? So because all the consecutive sides, that's what we're going to write, are perpendicular, we could say that this is a square or a rectangle, right? So I'm going to write that, okay? Then we can also talk about the diagonals, can't we? So here's our diagonal JL. So if we talk about JL, actually let me draw that in a different color. JL right there, okay. So JL, we do rise over run and we square those numbers, right? So if we want to find the length of that, then we got our 3 tall. So we're doing 3 squared plus 6 squared, right? So that's going to be 9 plus 36. So that's going to be the square root of 45. And hopefully you can see that MK is the same, right? Because it is 3 tall and 6 wide as well. So this is equal to what? MK. And so we can say the diagonals are congruent. And because the diagonals are congruent, and we would write that as a mathematical statement of JL is equal to MK, right? So diagonals are congruent, so that means this is a rectangle, okay? So those are the two distinct, or the properties, distinct properties that qualify this as that. Okay, so this next one is A, B, C, D. So I'm going to plot this again. A, B, C, and D. So it's either a parallelogram or it's a rhombus, right? Can't be a rectangular square because it doesn't have right angles at the intersection of the sides, right? Where the consecutive sides are. Okay, so let's find the length of AB and BC. So if we find the length of AB, it's 1. I don't know why it's not letting me choose different. 1, 2, 3, 4 wide, and 1, 2 tall. So if we look at AB, what's the length of AB? 4 squared plus 2 squared, so that's 16 plus 4, so that's equal to the square root of 20, right? Okay, so now let's look at the another side, BC. So this is 1, 2, 1, 2, 3, 4 as well. So we can see that that's going to be the same, right? Let's keep going around the shape. 1, 2, 3, 4, 1, 2, same. So that's going to be DC. And then we're going to do it with this last side. So we're going over 1, 2, and down 1, 2, 3, 4. So we can see that all 4 of these sides are congruent, right? So 4 sides congruent, so that means it's a rhombus, right? Okay. Now we could also use one other property. We could compare the diagonals here. So the diagonals here, let me see if I can do this in a different color. So there's one of my diagonals, DB. So DB, the slope of DB is 1, 2 down, 2 over, right? So DB slope is 2 down, 2 over, so that's a negative 1. Then we could compare that with AC up here. Okay, so we're going to look at the slope of AC. So this one's 1, 2, 3, 4, 5, 6 over. 6 up, sorry. 1, 2, 3, 4, 5, 6 over. So AC slope is 6 up, 6 over. So that's 1. So we can see that these slopes, DB, is perpendicular to AC, right? And because they're perpendicular, that also tells us that this is a rhombus. Okay. Number 9 says, given the following line, identify the line that is perpendicular and parallel to the original line through the given point. So first thing we need to do is find the slope. So this is what we're going to do. 1, 2, 3 up, and 1 over. See that? So our slope is 3. So what is the perpendicular slope? We're going to flip it, so it's going to be 1/3, and it's going to be negative, right? Okay, negative 1/3. Okay, so we're going to use that slope with the line y equals mx plus b, that equation, right? So we're going to plug in x and y here. So we're going to do that first to find our perpendicular line. So we're going to use our perpendicular slope. So we're going to do 5 equals our negative 1/3 times our negative 4 plus our b, okay? So that's 5 is equal to negative times the negative is positive, so that's 4/3 plus b. So we're going to subtract 4/3 from both sides, so that means b is going to be equal to 3 2/3, okay? So that means my equation here would be y is equal to negative 1/3 x plus 3 2/3, okay? Now we're going to do our other one, and we're going to use our parallel slope now. So we're just going to put our 5 there, and we're going to do our 3 times our negative 4 plus our b. So this is going to be 5 equals negative 12 plus b. We're going to add 12 to both sides, so that's going to be 17 equals b. So this one's going to be y equals 3x plus 17. Okay? So doing the same thing with the one below. Again, same slopes, so we don't have to change the slopes at all. Okay, so what for this? So now this time, let's see, we've got negative 3 equals our negative 1/3 times our 6 plus our b, okay? So negative 3 equals, That's going to be a negative 2 plus b. So we're going to add 2 to both sides, right? So that means this is going to be negative 1 equals b. So this is y equals negative 1/3 x minus 1. Okay, now we're going to do our other one again. So here again we're saying negative 3 equals 3 times 6 plus b, right? So that's negative 3 equals 18 plus b. So we are going to subtract 18 from both sides. So b is equal to negative 21. So we're going to plug in again our slope, y equals 3x minus 21. Okay? All right, so our next one is, given the following points on a graph, find the length of each side and the perimeter to the nearest hundredth. So I'm going to start with this wx right here. Okay, so we're going to go 1, 2, 3, 4, 5, 6, 7 down and 2 over. So with wx, we are going to say 7 squared plus 2 squared, right? So that's going to be 49 plus 4, so that's 53. And notice that this side on the opposite side, let's see if it's the same. 1, 2, 3, 4, 5, 6, 7. 1, 2 over, right? So these are the same. So wx and yz are the same, okay? So let's do that with our other side down here, xy. We're going to go down 1, 2, 3, or actually up 3. 1, 2, 2, 3, 4, 5, 6, 7. So again, so with xy, we went 7 over and 3 up, right? So that's going to be 49 plus 9. That's going to be 58. And let's see if this opposite side is the same as well. 1, 2, 3 up. 1, 2, 3, 4, 5, 6, 7 over. So that's the same. So that's wz. So that means we can say, to solve this, can't we go 2 times 53, the square root of 53, plus 2 times the square root of 58? That is 29.79, okay? So now I want to talk to you all about this next one. This is in the diagram. AB is congruent to CD. Find the length of X and the lengths of all the rest, okay? So let's look at how this looks on the diagram here. So if we say that AB, that's 2x plus 5x plus 7. If we say that that's equal, because that's what congruent really means, to what? CD here, that's 5x plus 7 plus 3x minus 4. So what do you notice on both sides of the equal sign? 5x, 7, 7, right? So that leaves us with 2x equals 3x minus 4. Well, that means that this segment right there and this segment right there are congruent, doesn't it? Indeed. Okay, so let's subtract 3x from both sides. So that gives me negative x equals negative 4, and then I can either divide or multiply by negative 1, so x is equal to 4 here. So then what is 2 times 4? That's equal to 8 right there for AC. So AC equals 8. Okay, then we do 5 times 4, that's 20 plus 7, so that's what? 27. So that means CB is equal to 27. And then 3 times 4, that's 12, minus 4 is also 8, right? And we thought that that should have been 8 anyway, so CB is equal to 8. Then it's asking us for AB, so we're going to add the 8 in the 27. So when we add the 8 to the 27, let's see, AB. AB, 8 and 27 is 35, right? And then we've got CD is equal to, CD would be the same, 35, wouldn't it? And then AD is the whole length, right? AD. So we're doing 35 plus 8, so that would be 43. Okay? Number 12 says S is between RT, RS is, okay, so we're going to go ahead and draw this. So we're going to draw R and T. And it doesn't tell me where it is, it just tells me it's between somewhere. So I'm just going to put it in between somewhere, and then I'm going to label 2x plus 8 here, and then RS. ST is 32, and then it tells me the whole length is 4x. Y'all see that? Okay, so now we're going to do the segment addition postulate. So we're going to do 2x plus 8 plus our 32, and that's going to be equal to our 4x, okay? So we're going to combine our 8 and our 32. That's going to give us 2x plus 40 equals 4x. So we're going to subtract 2x from both sides. So 40 is equal to 2x. Divide both sides by our 2. So x is equal to 20. Now to get our answers, we got to plug that back in. So if we're looking for RS, we're going to say 2 times 20 plus our 8. So that's going to be 48, right? Okay. Then we've got ST, and ST is already given to us as 32, isn't it? And then it's asking us for RT, and it's just doing this so we can think through the problem, okay? So RT is going to be equal to what? 4 times 20, so that's 80. Now, why did we want to do all pieces? So if we add 32 to 48, what do we get? Yep, we get 80. That's a great way to check the problem, y'all, okay? So let's look at this next one. This one is a little different because it has the word midpoint, okay? So we're going to draw our TV again. TV, and this time we're going to put S, what we think is about the middle, and we're going to put tick marks on here immediately, okay? So it says TS is 4x minus 9, right? It says SV is 5x minus 15. Okay, so what does that mean if those two tick marks are on those segments? It means they are equal, right? So that's exactly how we're going to set this up. 4x minus 9 is equal to 5x minus 15. So I'm going to subtract 4x from both sides. So that's going to give me x over here. And I'm going to add this 15 to both sides, add it over here, then cross it out, okay? So that's going to give me 6 over here. So x is equal to 6. Now we're going to plug that 6 back in. So for TS, that's going to be 4 times 6. That's 24 minus 9. And that is 15, right? So our other length should be 15. So let's look at SV. SV is equal to 5 times 6, that's 30, minus 15, guess what? That's 15 again, okay? So what is the whole length? 15 plus 15. Hopefully you guys can do that in your head. TV is equal to what? 15 plus 15, so that is 30. All right, so our next two are angles, okay? So we're going to draw them. It says P is in the interior of M and O. So we've got M, N, and O, and we have P in the interior somewhere. We don't know where, but we just know it's inside there somewhere, so we're going to draw right through it. Remember, we're just using this drawing for to use to solve the problem. So then it says MNP, which is the top angle, 5x plus 7, right? Then we got ONP, which is 3x minus 2. And then it says the whole thing, the whole big angle is 10x minus 25. So we're using the angle addition postulate here. So we're going to add the top angle, 5x plus 7, to the bottom angle, 3x minus 2, and it gives us that whole big angle. That's 10x minus 25. So we're going to combine our like terms on the left side. So that's going to give us 8x plus 5 equals 10x minus 25. So we're going to subtract 8x from both sides here. So that's gone from there, and we get a 2x over here. We're going to add 25 to both sides here. So that's gone from there, and that's equal to 30. So x is equal to what? 15, right? Because 2 goes into 30 15 times. Okay. So now we're going to plug that in. So we're going to find the measure of angle MNP. So to do that, we're going to do 5 times our 15. That's 75 plus 7. So that's equal to 82 degrees. Okay, then we're going to do our next one down here, this angle right here. So that's the measure of angle. What is that? ONP, and that's going to be equal to 3 times 15. That's 45 minus 2. So that's 43. Now, when we add those two together, that's 125, right? So that's what this whole big angle should be if we got the right value for x. So we're going to do the measure of angle MNO, okay? And that's going to be equal to 10 times 15. That's 150 minus 25. Guess what that is? That's 125. Okay, so again, add those two together, the 82 and the 43. If they equal the 125, then you got the right answer. Okay, so here's our last one. RS, it says bisects angle QRT. So we're going to do QRT and RS. S is going to be a dot in here somewhere. Well, actually, this time we know what. These two angles are congruent, okay, because it says bisect, okay. So we're going to go ahead and put in the top angle QRS, that this is 3x plus 18, and then this bottom angle is going to be 9x minus 12. And we know that those two angles are equal, right? So we're going to say 3x plus 18 equals our 9x minus 12, okay? So as we work through this problem, I'm going to subtract 3x from both sides. So that's now gone, and we got 6x over here. I'm going to add 12 to both sides, because remember, our goal is always to get all the variables on one side and all the constants on the other, okay? So this is equal to 30. 6 goes into 30. How many times? X equals 5. Yep, so now we got to find our angles, okay? So we're going to find the measure of angle. Actually, let's do it in black. QRS, that's going to be equal to 3 times 5, which is 15, plus 18. 15 plus 18 is 33. So because these angles are congruent, the bottom one should be 33 as well. So the measure of angle SRT is equal to 9 times 5, that's 45, minus 12. Guess what? That's also 33 degrees. Okay, so immediately you should be able to see that the big angle should be 66 degrees, right? So we're now going to find this right here. And how do we do that? We just add those two together, right? So the measure of angle QRT is equal to 33 plus 33, and that's 66 degrees.